In the last movie, I showed you how to exit from Mongo. So the first thing we need to do is get right back into it. So let me type in Mongo one more time. And now let's start taking a look at some of the basic CRUD operations. CRUD, if you've never heard the acronym before, stands for Create, Read, Update, and Delete, the basic operations performed on most database systems. The first step is to actually create a database. Most relational systems have a command for creating a database along the lines of create database and then giving it a name. There is no such command in Mongo. Instead, what we do is we use a database, and if it's not there, then Mongo will create it for us. If it is there, then it will switch to it. So we just need to give our database a name. We're going to build a little database that allows you to track your planetary exploration activities. With all of the new stars with planets being created, it's always a good thing to be able to track all the new planets as they're being discovered. So we're going to make a database to hold the planets. So we'll call this PlanetsDB. Now that we've created a database, we need to work with the collections in this database. So one of the first things you generally want to do as you're signing on to a new system is see what collections are already here. Now we know it's going to be empty because we just created it. But let's say we didn't know. So let's type in db.get collection names. So DB is just a reference to database. It's the currently selected database. And you're going to notice that a lot of the commands that I'm typing in look an awful lot like a programming language, maybe JavaScript, maybe Python. This is intentional. Remember, one of the great things about this system is that you get to work with data in the same format used by your favorite programming languages. So I'll hit enter here, and I get ostensibly an empty array, meaning there's nothing in here right now, which is what we expected. So why don't we next then create a collection? As with databases, there is no create collection command. You simply insert a document into a collection, and if it doesn't exist, then it creates it and then does the insert. If it already exists, naturally it just inserts it regularly. The document that I want to insert is kind of long, and it probably wouldn't be enjoyable for you to sit here and watch me type in a big long JSON string in here. So why don't we take a shortcut on some of these longer ones? A few lessons back, I gave you a cheat sheet. The cheat sheet looks like this. And if you scroll down a little ways, you'll find the document that I'm talking about. It's this one right here, inserted document. You can kind of tell we've done all of these commands that are before it, so we're just sort of going down the cheat sheet in order. So what you can do is just copy this and paste it into the window, which is exactly what I'm going to do. So I'll copy the text in, I'll paste it, I'll scroll up a little bit just so you can see what's going on. So here's where I started my paste, db.planets.insert. So we're working in PlanetsDB, but inside of that DB, we have a collection called planets. Now it wasn't there, but this is what I was talking about. When you insert into a collection that doesn't exist, it creates the collection and then inserts the document. If it already exists, then it just inserts the document. So here we have a fairly rich object structure, which is why it's so long. I wanted to make sure that you understood that you could use the full power of JavaScript object notation in order to save your data. Now under the hood, it's technically a binary version of JSON called bson. But for all intents and purposes, as we work with it, it's pretty much working with JSON. So here we are inserting Mercury. We've got a few salient points here. The planet type, this is a reference for all you Star Trek fans. What kind of planet is it? Everyone knows Earth is an M-class planet. There's different classes of planet that determines its habitability, and this is purely fictitious. So if you are an astronomer, please don't spam my email with hate mail. That's not cool. Next we have mass, radius, distance from Earth, nearby stars, which in this case is an array. And then we have an object down at the bottom, discovered by, and then in our object we have first name, last name, year, and where the discoverer was from. So when I pasted this in, it went ahead and wrote it, and it says write result in inserted 1. So that's always a good sign. When you do these kinds of operations, it tells you how many rows were affected, and we would expect to see 1 come back because we just inserted 1 row. Later on, when we look at update and delete, it will also tell you how many documents, whatever it was that you did, matched. So if you're going to delete something, you want to know its ID, you delete by the ID, you should get 1 back, that kind of thing. We'll see that later, though. So we've got C in Crud, the create part, taken care of. Why don't we look at R for read? Let's read back all the data from our database, or from our collection, rather. To do that, we'll type in db.planets, which again is db. It's always going to be db, dot the name of the collection that you created, and then dot find, and then let's tack on something to the end of it, dot pretty. Everyone wants pretty. So when we hit this, we see the data that are in this collection. So just 1 record, but you'll note that it is added in this object ID. So this happens automatically. It's got an underscore in front of it, so watch out for that. You don't want to call any of your fields underscore object ID. That would be weird. This is reserved by Mongo to store your object IDs. And again, your object ID just uniquely identifies this record. So in a relational system, you often have primary keys that are auto-generated by the database, but they're usually nice numbers, just normal integers. On Mongo, they actually use UUIDs or GUIDs, which is this big long string of letters and numbers here. Generally speaking, these are supposed to be unique, completely unique, so there should be no way that it would be possible to generate the same ID twice. So that's why they went with that. That's a good thing. There are relational people out there that use GUIDs, so it's not unheard of in the relational regions as well, but for Mongo, it's the norm. Beyond that, this is just a copy of the data that we put in here. So you might be wondering what that pretty command was. If we take the pretty off and type, no, I'm just kidding. Just take the pretty off and just do find by itself, you'll see we get a much less pretty answer, albeit a correct one. So pretty just makes the nice formatting, makes it easier to read, easier to work with. But as we get into working with programming languages, that pretty isn't really going to matter because your program is going to be dealing with it, not you. And it's completely happy with objects coming out of the database in this format, not pretty. Okay, so the planets.find command, the find command, gives you all of the documents that are in the current collection. What if we just wanted 1? So let's take a look at looking up 1 document, 1 single document. We'll do db.planets.find1, and then we need to give it some criteria. So for criteria, normally you have nothing in this parenthesis, but this time we're going to add some criteria, and this is going to look an awful lot like an object in JavaScript. So what I'll do is I'll do a search on the field _ID to get that unique ID, and I'm going to need that. So let me scroll up, and I'm going to grab the whole thing, including the word object ID, the whole thing. I'll copy it with Command or Control C, and then I shall paste it like so. So I didn't put quotes around it, I just pasted it exactly as is. So now we've got planets.find1, and we're searching on ID. I'll hit enter, and I'll get that same record right back again. But in this case, if there had been multiple records in there, it would have just given me the first one that matches that criteria. And since I use the ID that is unique, naturally I would assume that it would only be 1 record that would come back. As much fun as it is to be working with one record, it'd probably be a lot more fun if we had multiple records. So let me switch back to my cheat sheet and look for the command here that does db.planets insert many. You definitely want to copy this one. So let's copy the whole thing all the way down to Pluto. And we'll paste it in. And I'll go ahead and hit enter. And you can see that the result is slightly different. It acknowledges that you did the insert, and then it gives you back a list of the IDs in an array. So let's scroll back up and take a look at the command one more time before we move on. So this one was db.planets.insert many. So the difference here is that we're not passing in a single record, a single document. We're passing in multiple documents in the format of an array. So this is an array of objects or an array of dictionaries, depending on which programming language you're talking about. But they all support this kind of object data structure. So now we should have lots of records to play with, 9 to be precise. So let's try that find command again. So let's do db.planets.find.pretty. And we get a nice long list. I can see Pluto is here, so it definitely worked. I could scroll up, but I think you believe me. So that find command is giving you back everything. This would be like select star from table name in SQL in a relational system. So we've seen find all. Let's change this up a little bit. This time we've seen searching on object IDs. Let's do something a little more generic. So this time I'm going to find the planet Earth. To do that, I'm just going to modify what's inside of the parentheses on find. And I will add in the object that represents what I'm looking for. So in this case, I'm looking for planet name. And I'm looking for that to equal Earth. Now it's find and not find one, so if there were multiple Earths, maybe if you're a comic book fan, you know there's multiple Earths. But in the real world, there's only one. We should only get one record back. But if there were multiple elements in here with the planet name of Earth, we should get them all back. So I'll hit enter, and now I've just got Earth. As you can imagine, you can get a lot more complicated with this just by expanding what you put in this object. And we'll get to more advanced queries a little bit later where we look at maybe manipulating some of these numbers. But anything that's in this object graph you can use as a search term in here. And this even works if not all the records have the exact same structure. It's just going to return all the documents that have the object structure that you're asking for. So that's one of the big differences between Mongo and a relational system. It isn't required that all documents conform to a particular schema. They can have any structure you want. Okay, just in eyeballing this data, I can see there's an obvious error here. Planet Earth, as we mentioned, is not an X-class planet. That would make it really uninhabitable. It's actually an M-class planet. So why don't we take a look at how to update this? For that, we'll do db.planets.update. And for this one, we want to do a couple of things. We want to basically put a qualifier in here. This would be like a where clause in a select statement in a relational database. So we need to find which records we want to update. If you wanted to update one, you could use the object ID, but we're not going to do that. We're going to basically update everything with planet type X, and we're going to change it to planet class M. So let's do that. For that, I'm going to search on planet type. And I'll set it to X. So that's the first part. The first argument in this is the search term that qualifies what you want to update. So all records with a planet type of X. And then there's a second argument here. And this is what we want to actually set it to. So for that, I'll do open curly brace, $set, and then I'll include the object with all of the updated information in it. So I'll say planet type, and we're going to set it to M. And I almost missed that brace, didn't I? On my command prompt, it actually shows me where these closers are. So that's really handy. Hopefully yours does too. I do most of my work on the Mac and on Linux. Your mileage may vary in PowerShell. Okay, so this looks pretty good. Let's hit enter. So we can see n matched is 1, so the number of documents matched is 1, which is what I expected. There was only one X-class planet in our data. Next it says number of records upserted. An upsert is basically an idea where you insert a document, and if it's not there, then it inserts it. If it is there, then it updates it. And we didn't have any of those. So that just leaves number of modified records, again, 1. That's exactly what we would expect. These are usually going to be equal to each other, these two values, in modified and in matched. All right, so let's check our work. I'll hit the up arrow a couple of times because I know I have a search in here for planet Earth. So let's see if it is in fact an M-class planet now, and it is. Within the realm of Crud, we've done create, read, and update. That just leaves delete. And I do this with a heavy heart. I really hate doing this because when I grew up, Pluto was a planet, and the current generation has decided to defame it and make it not a planet. I think we should bring back Pluto. So let's look at how to get rid of it, how to delete it. First, we need to find it because I'm going to delete it based on the object ID. So let me do db.planets. Actually, let's just use that same query we did a second ago, but let's just change our search term to Pluto. That's faster. Perfect. I've found Pluto. There's its object ID. So let me grab it. Command or Control C to copy. And now I'll type in db.planets.remove. And I need a qualifier. Again, this is an object that defines what it is that you want to delete. So it's the same pattern as you would see when you're finding and when you're updating. To finish this off, I'll put _ID in here, and I'll set it equal to the object ID that I copied. Close my braces. And I can see that only one record was removed, which is what I expected. So now when we do db.planets.find.pretty, we can see that the last planet on here is Neptune. Sorry, Pluto. I felt really bad doing that to you. Who knows, maybe they'll vote you back in one day. So now we know basic operations. We can create a database, we can create collections, we can create, read, update, and delete documents from those collections. In the next movie, we'll take a look at slightly more advanced queries where we're able to filter on number values, greater than, less than, logic, things like that.